Today we're going to be investigating how light intensity affects photosynthesis. We're going to be using single-celled algae in an alginate which makes these little algal balls, which you can see there, these kind of little jelly type balls containing algae which will then photosynthesize when exposed to light. So what we're going to do is we're going to place some of these algal balls into these little glass vials here. We'll add an indicator, sodium hydrogen carbonate indicator, which will then change colour depending on how much carbon dioxide is either removed from the indicator or placed into the indicator. And that will give us an indication of first of all, the pH of our new solution, which we can then measure against a scale. And from that scale, we can then determine how much photosynthesis has been taking place at each of the different light intensities. So the idea is we'll add some algal balls to the vials, and we'll then place those vials at equal distances along a ruler away from a light source. So a lamp at one end of the ruler, vials containing the algal balls and the indicator at equal distances away from the light source. We'll then leave them for a while, and when we return, if there is a colour change, that will indicate as to whether carbon dioxide has been removed or whether carbon dioxide has been produced. So to begin with, all we're going to do is take our algal balls and we're going to place them into our vials. So we'll just take this. We need to make sure that we're using an equal number of algal balls in each of our vials. This will be one of our control variables. So we need to make sure that we're being aware of what variables need to be controlled in this, which variables need to be kept the same in each of our vials. And one of those is going to be the number of algal balls we're going to use. We're going to use 10 of these algal balls in each of our vials. You can see they're a little bit tricky to get into the vials. We want to be very careful with them. We don't want to damage them with our tweezers. If we squeeze them too hard, they'll break apart, and that difference in terms of the algal balls will then change the amount of surface area. It will change the amount of exposure that the algae has to the light, and we no longer have our control variable in place. So we want to make sure that the balls remain intact. We want to try and, if we can, potentially use them about equal diameter, so balls of about equal size. Again, to try and control things as much as possible and try and keep things as equal between each of our different vials as possible. So 10 algal balls into each of these. So we've got there now 8 of them. And that makes 10. So I'm going to continue and I'm going to add the rest of the algal balls. You don't need to be watching me doing all of that. So you can see we've now got our algal balls into our vials. We've set up 6 of these vials. 5 of them will be placed against the light at various different intervals, and the 6th one we will then use as a control. So not a control variable. There's a big difference between control variables and a control. So the control variables are the factors that we need to keep the same in each of our experiments. So for example, the number of the algal balls, the indicator which we're now going to add, making sure that we're using the same volume of the indicator, not the amount of indicator. Make sure that if you're ever talking about control variables that you say that it's the volume of a liquid, so it'd be the volume of our indicator, and also the same concentration of indicator in each of our vials. The last vial will then be a control, and a control is one where we remove the independent variable. So the factor that we'll be looking at here is how light intensity affects the rate of photosynthesis. So if we remove the light intensity altogether, then we've got something to compare against. And for that purpose, what we will do is we will then take our 6th vial with the same indicator, the same algal balls, so the same control variables in place, but we will remove the light by wrapping it in foil, and that then becomes a control that we can then use to compare the rest against. So in terms of the indicator, we're going to use a pipette, and we're going to very carefully add 2 millilitres, 2 centimetres cubed of our hydrogen carbonate indicator to each of our vials. You can see that it is this rather nice kind of cherry red colour. That is its initial starting colour, and that represents a pH of 8.4. So we already know what the starting pH of our indicator is. So at 8.4. Now, if carbon dioxide is then added to the indicator, then our indicator will change colour, and it will go a lighter colour. It will start to go orange. So it will change colour from this kind of pinky red colour to a more orange colour. If carbon dioxide is removed from our indicator, then it will start to get darker, and it will start to go, first of all, a sort of a more pinky colour, and then eventually it will go purple when the most amount of carbon dioxide has been removed. So that will be at the highest pH. So as we get more alkaline, it means more carbon dioxide has been removed, and we get that darker colour. As more carbon dioxide is put into the indicator, it becomes more acidic, and that becomes then a more orangey colour. So we've got our 2 millilitres, again, our 2 millilitres, the equal volume in each one, so our control variable in place. We have our algal balls on place. We then add lids. We don't want any carbon dioxide from the air affecting anything as well. So we add our lids to our 6 vials, and when we're then going to wrap one of those vials in foil so that it is then completely isolated from the light intensity will not be a factor. You'll notice that I've got a 7th vial here as well on the end, which doesn't have any algal balls in it, and that is simply so that what we can do is just add our indicator alone with no algae, so that what we've got is we've then just got a colour that we can compare against later. We've got a colour chart that we will use, but we would like to be able to just compare just the base indicator itself as well. We could use it in the flask, but now we've got it in the same size and same quantities as the rest. Okay, so we just put that one to one side, and we take some foil, and we're just going to wrap one of our vials entirely in foil, so it now has absolutely no light can get to it at all. We can see that we can just stand it there completely without any light. So the rest of our vials we're now going to get set up next to our light source. You can see here we have a lamp positioned next to a meter ruler. You can see that the meter ruler and the light starts exactly on the 0. So as we move away from here, we're going to place one of our vials at 20 centimeters. Our next vial we will then place at 40 centimeters. Then a third one at 60, a fourth one at 80 centimeters, and then finally one at 100 centimeters. And you can see we've got our foil one here as well. It doesn't really matter where that goes because no light can get to it, but we'll place it at this end anyway. And that is our 5 different vials then set up. You can see if we position like that, you can see that as we get closer towards the light source, obviously the light intensity will also increase. Now, it's quite possible that you may be asked what you could use to determine the actual light intensity itself. We're not expected to actually measure the light intensity, but if you wanted to, you could use this device here. So it's a light meter. So if we turn it on, you can see that we get a number on the display there. And as we get closer to the light source, that number will increase. So if we go to our 20 centimeter away vial, we can see that if we position our light meter next to it, we've got a reading there of around about 2,300 lux. That's our units of light intensity. As we move away and we go next to our 40 centimeter away vial, our number of lux has gone down to about 900. As we move to The next vial, you can see that the light intensity goes down yet again. Now we're at about between 450 and 500 lux. So you can see that we could, if we wanted to, we could put a quantitative value, a numeric value on our light intensity. We don't need to do that. We're just going to look at the distance and assume that the closer to the light, then the higher the light intensity is. So all we're going to do is we're just going to leave our vials there. We're going to leave them for at least an hour, and that will then give the algae enough time to respond to the light and photosynthesize. And then we'll come back and we'll compare the various different colours, hopefully, that we will have for our indicator, use that against a scale to judge the pH, and from that we should be able to determine how much photosynthesis has actually taken place in each of those vials. One last thing we need to do is, as you can see, there's an awful lot of light in the ceiling here, so we just need to make sure that that's all turned off, and then our only light source that is going to be affecting our vials is going to be coming from that lamp. There's no external light interfering with that at all, so then we can be sure that any light is just coming from this lamp, and as we move further away from it, the light intensity will in fact decrease. So we'll leave this now for, like I say, at least an hour or so, and we'll come back and see the results in a little while. So our algal balls have been in their indicator next to their light source for nearly a couple of hours now. We're just going to turn the main lights back on again now, they don't matter too much, and we can have a look at some of our results. So we can see that what was initially quite an orangey colour of indicator, a little bit pink, has now, in some instances, really gone quite a pink colour. We'll compare that to a scale in just a moment. We can see that that pink colour certainly decreases as we get further away from our light source. If we look back there, we can see the various different vials together. We can see that that pink colour certainly intensifies as we get closer to our light source. So what we'll do is we'll compare that now to a scale that we already have prepared that will tell us what the pH of these different vials are, and we can place them just here like this, so we don't need our meter ruler anymore. So this was the one that was at 20 centimeters, 40, at 60 centimeters, at 80 centimeters, and at 100 centimeters. We also, of course, have our foil wrapped vial, which we can now open, which, as we can see, is really quite an orangey colour indeed, much paler than the rest of them. So we'll use that to compare against a scale that we have just here. So we can see that this darkest colour of pink, which is probably at around about there at about pH of about 9 now, is noticeably higher than the 8.4 that we started with. And that means that carbon dioxide has been removed from the indicator. Now, if carbon dioxide has been removed, there's nothing else that could have achieved that unless it was the algae removing that via photosynthesis. So the photosynthesis has removed the carbon dioxide. The indicator has then changed colour and gone more purple, more alkaline, because carbon dioxide is more likely to make a fluid acidic. So if there was more carbon dioxide in there, then we're likely to get a more acidic solution, and therefore a paler colour. If we look at the algae and the indicator that was in the dark, so in foil wrap with no access to light, we can see that it's kind of right down at this bottom end here at around about pH of 7.8. The pH has gone down, which means that carbon dioxide has been introduced to the indicator. Now, if we've got algae in there, we've got living organisms in there, that's likely to have come from respiration. So no photosynthesis has taken place because there's been no access to light. It can't react with the chlorophyll, so photosynthesis just doesn't take place. However, all living cells respire all of the time. So it means that while there's been no photosynthesis taking place, the algae has still been respiring and therefore producing carbon dioxide. That carbon dioxide has got into the indicator and turned it more acidic. So hence we've got that slightly different change in colour. We can see if we look at the scale, like I said, we've got about a pH of about 9 here on the 20 centimetre vial with the algae in it, we've got a colour of around about, that looks to me to be around about the 8.8 and the 40 centimetre. If we get to here, we're looking at possibly the 8.6 vial. As we get to the vial that was at 80 centimetres, quite a long distance from that light. It's not a particularly bright light, and I would say that we're probably at around about the 8.4 that we probably started at. So it hasn't really changed much at all. So what that suggests is that whilst we know the cells have definitely been respiring, they're living cells, they will respire and therefore produce carbon dioxide, the colour hasn't got any lighter, it hasn't turned any more orangey colour, which means that there must have also been carbon dioxide removed from the indicator as well, and that's happened because of photosynthesis, just not as much as in some of the other vials. And as we get down to the last one that was at 100 centimetres, I would say that we're probably at a scale here at about 8.2. It looks like we have got a little bit more acidic, but only very slightly. So it looks like the respiration that's been producing the carbon dioxide has been taking place slightly more than the photosynthesis. It's certainly not as pale as our one that was in the foil, which means that some carbon dioxide has been removed, or not as much has been put in. If we've got the same amount of algae, they should all be respiring about the same all of the time, which means that the only other factor really that we can assume from this that has therefore removed carbon dioxide, replacement from the carbon dioxide that's been put back in by respiration, is through photosynthesis, just not very much in that last vial. So all of them respiring all the time and therefore putting carbon dioxide in, that should turn the indicator pale. However, photosynthesis occurring much greater rate with a higher light intensity, closer to the light, and therefore we get an awful lot of carbon dioxide being removed from the indicator, more carbon dioxide being removed, a little bit less, and as we get further away from the light source, a little bit less carbon dioxide each time being removed, because there is less photosynthesis taking place, because we have less light to react with the chlorophyll.